get started. First, welcome to this mini workshop. So this is an introduction to Python for community members, K-12 teachers, and the students. My name is Feng. I'll be teaching this workshop for today. Let me go to the slides. As I mentioned earlier, we have the slides ready. If you follow the URL, which is in the chat room, you can see the slides as well. So I'm assistant professor from the University of Michigan-Dearborn, from the Industrial and the Manufacturing Systems Engineering. So if you're high school students, if you're interested in our undergraduate programs, from the slides, we provided a link to our department. You can check what programs we have. And essentially, the data analytics is a big part of it, because whenever you're doing any kind of engineering, you'll be dealing with data. So it's an essential skills that we'll teach our students. And also, we have our department is on social media. Feel free to follow us. So it's UM Dearborn, IMSE. So that's our department. We're on Twitter, Facebook, and LinkedIn, and other social media. So for today's workshop, we're happy to have three teaching assistants helping us, Jackie, Milrish, and Dania. So they're all PhD students from our department. So if you have any questions during the workshop, you can post it in the chat room, and our TAs will try their best to answer your questions, okay? And thanks to our TAs. So first, I want to briefly talk about why do we want to program in data analysis. So every time when I'm teaching a session like this, some student may ask, why don't we just use Excel, right? So the reason that we want to use programming in data analysis, so here I listed the three main reasons. So first, it's very flexible and customizable. So because in programming, you can write functions, you can write your code by yourself rather than relying on some pre-built function from, for example, some commercial software where you are kind of limited to whatever the functionalities that they provide. So if you program, you have a lot more flexibility to work on the problem you're facing. And also the second one is reproducible research. That is very important. So whenever you are doing analysis, you want to make sure that your work can be reproduced by your colleagues and by other people, so that we know that your analysis is valid. So that's very important whenever you're running a study or doing a research. But it's much easier to do if you write your analysis in code rather than using some graphical user interface, because other people can just rerun your code. They can reproduce your work. If you're using a graphical kind of user interface, you perform the data analysis by clicking buttons. So those kind of things are much harder for other people to reproduce your work. And the third one is if you program for data analysis, it's much easier to collaborate with other people, some other people in your team, or you're communicating with another team, or communicating your results with the public. So that's much easier to do if you perform your analysis in programming. So that's a reason we sometimes we want to use programming for data analysis. And the next slide shows why do we want to use Python. So Python is, here I listed the four main reasons that I believe are the very important reasons why Python is important. So Python is an open source platform language. So it basically have the benefits of all the open source softwares. So it's free and it's widely available. There's no barriers. You don't need to pay anything in order to use this. So there's no barriers for that. And it has a massive open source community. So it's built by the community. So and also it's one of the most mature languages out there. So if you have a question, if you Google it, chances are someone else have already asked the exact same question. So it's a lot of resources out there. And also another thing about Python is it has a lot of the very useful libraries, either standard libraries or third-party libraries. So libraries essentially a collection of functions that are built by some other people that you can directly use for whatever the purpose you want to use, rather than reinvent a wheel and write your code from the beginning. So Python has a lot of the libraries, especially you're doing the data analysis or machine learning, artificial intelligence. Python have a lot of very powerful libraries out there you can directly use. And lastly, Python is compared with other languages, it's rather beginner friendly. So it's compared, if you know some other languages like a C or Java or C++, Python is more of a higher level language. So you don't need to worry about a lot of those lower level details. So that sometimes make it a lot easier for beginners to learn. And also, it's some people may even say that Python syntax is it's rather easy to read and write. Some people even say it's you can read it like a plain English. So that's Python. And here I want to talk about the purpose of this workshop. So obviously we only have an hour and a half, so you're not going to be a Python expert after this workshop. But the purpose for this workshop is essentially to help you to build some basic skills and to gain some confidence of using Python. And we're going to provide you with some hands-on experience. And it's really to get you started, to help you to have this very first step that after the workshop, you can continue learning by yourself. So that's the purpose of this workshop. So the plan for this workshop is for the first part, we will actually asking Dr. Barbara Erickson. So Dr. Erickson is a professor from the U of M School of Information, and she's going to talk about some of the Python learning resources that are going to be really helpful if you want to get started with programming in Python. So without further ado, I will pass it to Dr. Erickson.
Great, thank you, Fred. And I'm going to share my screen. Oh, you'll have to allow me to share a screen. It says the host disabled screen sharing.
Okay, you should be able to do it now.
If you make me, yes, now I can. Terrific. So I just put in the chat window a URL. So I've been involved in creating free and interactive ebooks for many years now. And one of the first ones we created was one for people that are teaching CS Principles, which is an advanced placement course. And that's using Python. And we created this, there's both a teacher and a student version. So I gave you the URL for the student version. You can just change it where it says student to teacher to see the teacher version. And they're similar, oh, except I don't have it in here, hang on. I have so many books that it confuses it. Oh, I'd have to add it, I guess. So I'm going to stay in the student version for now, but you can add the teacher version as well if you just change the name student to teacher. But the idea was that, especially for secondary teachers, they're not going to be software engineers, but they do need to be able to read code, reason about code, fix code, run code. So we made an interactive ebook that has a lot of examples that you can run. So this is examples showing something about variables or assigning names to things, which is one of the key things we do in programming. But then it's followed by lots of multiple choice questions or fill in the blank questions. So particularly, I like to start with showing about working with turtles. So Seymour Papert was a professor at MIT back in the 60s, and he created the Logo programming language. And originally they had a robotic turtle that had a pen in the middle, and you would command the turtle to go forward or turn left or turn right. And as the turtle moved, the pen would draw. And so that's what this code is doing. This is Python code for reading from a turtle library, creating a screen for the turtle to draw on, creating the turtle, naming it Alex, and then asking it to go forward 150, asking it to turn left 90, and then go forward 75. So this is the kind of thing we have in the ebooks, where we have working code that you can run and modify. So what happens if I go forward just 50 instead? So I could just change this and try it. Or what happens if I go right instead of left? So working examples you can try. You could also listen to an audio tour explain the code. So you can click on a line-by-line
First
tour.
line of the program makes the turtle functions available. The second line creates a space where the turtle can behave. The third line creates a turtle and gives.
So this is helpful, especially for teachers that are new to Python, as a way to show you how to talk about code. And then each of these examples are followed by questions to get you to think about, like, which way does a turtle face when it's first created? And you get immediate feedback for every answer, if you answer correctly or incorrectly. And then in particular, one of the things I was doing for this book was giving you, instead of making you write equivalent code, which can be hard, is giving you mixed up code to solve a problem. So if I want to draw this instead, how would I do that? So I have to figure out, there are pairs of correct and incorrect code. So this is from turtle lowercase import star or from turtle uppercase import star. I might have to go back and check that example to see, oh yes, it's lowercase import, but oh look, screen is uppercase and turtle is uppercase. So that gives me a clue about what's important here, and that fact that Python is case sensitive. Case does matter in Python. So I import the library, I create a screen, I create a turtle, name it Ella. And then since I would normally go east, I'd have to turn to go south, which would be a right turn. And I'd have to decide, is it right or turn? And I go forward a long amount and then turn and do a shorter amount. So I see there's a forward 150. If I was facing south, I'd have to turn to go east. That would be a left turn. And then say that I clicked the wrong block here. So when I think I'm ready, I check my solution. And if I use the wrong thing, it'll highlight in red. That may be enough for me to realize, oh, I meant a forward here. And I see that now I'm correct. We've also made this so that if you are struggling to answer the question, so I'm just going to grab a bunch of the blocks. And if I check a solution and I have several errors and I try to solve it at least 3 times without being correct, I get a note that there's the help me button will make it easier for me. So if I click the help me button, it's going to remove incorrect code block. So it animates it going back to the left side and grays out. So that means, hey, I should probably use this one. It'll keep removing incorrect code blocks till I get rid of all the incorrect ones. And then, oops, I still have one more incorrect. Once I'm done with all the incorrect, it'll start combining blocks, and it moves blocks together that are the furthest apart, which gives you more information about the solution. And it'll keep doing that till I get down to 3 blocks. And then it'll tell me I should be able to put those 3 blocks in order. And in fact, they already are in order. So I just wanted to make you aware of, this is a book for people learning to program in Python, not necessarily with any prior programming experience. It's for the AP Computer Science Principles course. There's both a student version and a teacher version. And if you are also interested, there are other books on Runestone, particularly for CSA. There's a book called CS Awesome. And the CSA exam is an object-oriented programming in Java exam or course. And so this is actually College Board endorsed curriculum for that, and includes, we have a Google group of 1,800 teachers too that are contributing materials. So this is programming in Java, but you still have turtles for helping you do things. Whoa, where did that come from? Okay. Since I'm using the open version of the course, you may see ads occasionally. If you create your own course, which you can, create a custom course, then you wouldn't see those. So this is a turtle in Java doing a similar sort of thing, but now in Java. And you can see that Java is a lot more complicated. There's a lot more code that has to be here just to do something similar to what we were doing in Python. And if you want to see all the books, all the free ebooks that are available on Runestone, you just click this little picture on the left-hand side of the books. And that takes you to information about Runestone, you can see the list, which is the list of books. And there are several books for Python here that are free, including the one that started it all was How to Think Like a Computer Scientist Interactive Edition. That was the first one that was put on Runestone. There's a newer one, Foundations of Python Programming. And then one of the ones that I've been adding to recently is one for data science, a sort of a baby data science starter, which is Python for Everybody. And I'll put that in the chat window as well, the link to that. So this book is similar to a course we offer at the University of Michigan in the School of Information, which is where I'm at, for students who have some prior programming experience, but not necessarily in Python. And it covers Python basics, but also how to read, write from files, how to work with regular expressions, how to do network programming and read from APIs, how to use Beautiful Soup to scrape web data, how to work with databases, as well as a little bit about object-oriented programming. So this is another book you might find interesting as well. And I'll put that in the chat window, that link for that one. But I just wanted to let you know about some of these materials. That's CS Awesome. Oh, no, that's the right one. Okay. So that's the Python for Everybody link, and I'll put in the CS Awesome one as well. So as I said, there's public versions of all these books that anybody can use, but you as an instructor can also create a custom course. If you create a custom course, you can have your students register for your course. You can create assignments and see what progress your students have made on the assignments. You can use auto grading to grade the assignments. You can create exams or midterms even in Runestone. So quite a lot of capability. But I thank Fred for giving me an opportunity to share these materials with you as well. Are there any questions about any of that?
All right, thanks, Dr. Erickson. So I think if you registered for this workshop, we can also, so if you register, we have your email address. So after this workshop, we'll send the links to all the resources that we mentioned to you as well. So so expect an email from us. So we'll give you all the information with all these resources. So this looks very interesting. I think it's not beneficial certainly for teachers, but if you are a student or just want to learn, or if you're anyone really want to learn, these are, I think, really great resources to get you started in programming. Thanks, Dr. Erickson.
Thank you. Stop sharing.
All right. If you can stop sharing.
Yep. I did
Okay.
that.
Great. So let's get back to the second part. So for the second part, we will do some hands-on learning of Python. So for this part, we will use something called a Google Colab. So in order to do this, you will need to first go to our this URL with the with our slide. So it's just umich.edu/ and then followed by a wave sign followed by my full name and /Python. So and let me just copy and paste it to the chat room one more time. So if you go to this slide, and then if you scroll all the way to slide 9 here, and then we have the URL here in red. So what you will need to do if you want to follow along. So first, of course, you don't have to follow along. If you just want to watch me doing it, that's totally fine. But if you want to follow along, and oftentimes, especially in programming, you really learn by doing. So I would encourage you to try to follow along. So if you want to do that, go to this slide and then copy this URL. Oh, Jackie also pasted that URL into the chat room as well. So you can also just copy that URL from the chat room. Start with a GitHub. So once you have that, then you will need to go to Google Colab, and you will need to paste it. So once you open the Google Colab, so there are several tabs. So one of the tab is called a GitHub. And what you will need to do is to copy and paste that URL into this window here. And then you will need to search for it. Click this search button here, and then it will just load this this notebook that we'll be using for the rest of this workshop. Okay, so if you can see something like in my screen right now, so you're good to go. Okay, so I'll give people about 2 minutes to do this, and then we'll start. Okay, so if you have any trouble doing any of the steps to reach this page, please let us know. You can post it in the chat room so we can help you. Okay. All right, are people all at this stage now? Open this notebook. Great. Does anyone have an issue with this so we can help? So again, the step is if you go to, you need to copy this URL. So you can find this URL from this slide, or you can just, we have it posted in the chat room. So is this URL start with github.com, and then you go to Google Colab, and then paste it into the place under the GitHub tab. And then if you click the search button, it will just open up this notebook that will look something like this. Okay. Oh, great. It works now. And also, for those of you who are already here, so Notebook, it's essentially, it's so the Google Colab, it's the cloud-based version of the something called the Jupyter Notebook. It's a very great way for programming. It's essentially called a notebook because, as you can see here, there are notebook is there are cells. So for some of the cells, I can write code in it. And for some of the cells, I can also write some text for explanation or documentation or some other purposes. I can add pictures to the notebook and other things. So it's a great way if you want to analyze your data. So that's so Google Colab. It's an online version of it, and if you want to have a local version of it, you can also install that onto your computer. So we're gonna talk a little bit on that towards the end. Okay, so I assume people are already at this step, have their Jupyter Notebook open. So let's get started. So for this workshop, for this part, we will talk about, in part one, some of the most basic things about programming in Python. And then in the second part, we'll talk about how can we analyze data in Python, okay? And if you have any questions, if you get stuck or you have any questions along the way, feel free to post it in the chat room. And we have 3 TAs here to help you, so they can answer your questions, okay? So first part, let's talk about the Python basics. So at the, if you move your mouse here, so we have a cell here. If I hit enter, it will just add multiple lines. So first thing I want to talk about is the variable types. So in Python, we can create different types of variables. For example, I can type in something. Let me actually make this a little bit bigger for you to see. So I can type something like a equals, for example, 5. So we just assign a value of 5 to a variable that we call a, okay? So in order to run this cell, you can either click this play button. So that will run anyway. So it will just run this cell. And actually nothing really happens because we didn't really ask this program to do anything for us. But if I can type something like a print followed by a pair of parentheses, and then we put this variable we just created a here within this parentheses. And now if I run this, it will output the number 5, so which is a value for the variable a. Okay, so that's how you can create a variable a and then assign a value to it, in this case 5. Another thing, a very useful function in Python is called a type. I just type in type followed by a pair of parentheses, and then I put a in here. And now if I run this cell, it will just give us the type of this variable a. So as you can see here, the output is int. It stands for integer, meaning that a is a type of an integer number. So that's variable a. And we can also create let's create another variable called a b. And b equals to, let's give it a number, for example, 5.67. And now I can print out b just like before. And also I can check the type of b. So now if I run this cell by clicking this play button, it will print out the value for b, which is 5.67. And also it will show the type for the variable b. In this case, it says float, meaning it's a floating number. So it's 5.67. So that's in Python, we have integer, we have floating number. So we can continue. Let's create another variable. And in Python, we can also have a type which is a string. Okay, so if you want to have a string, for example, c equals to, let's say, go blue. You can type whatever you want. So essentially, we can have a string for that, and then we can try to print out C and check the type of C. So now if I run this, it will actually give me an error. And the reason for that is if you want to assign a string to a variable, they have to be within a quotation mark. Okay, so we have to wrap this thing within a quotation mark, and you can use either single quotation or double quotation. It doesn't matter, but you have to be consistent. If you start with a single quotation, you have to close with another single quotation. So now if now we wrap this go blue within this quotation mark, now if we run this, it will just print out the value for this string, which is go blue, and then the type of this this variable C, which is str, which stands for it's a string. You can consider that as a string or a text. Okay, so that's for in Python. We can also have a variable which is a string, and we can also have a variable which is a list. So now I'm going to type in d equals to, and then in Python, if you want to have a list, the list has to be indicated by a square brackets. Okay, so I have to type in the square brackets, and then I'll just type in a bunch of numbers. For example, 1, 3, 5, 3, 6. It doesn't matter. I'll just give it some numbers. And now if I can just print out this list and check the type for this D. And now if I run this, it will print out this list that I just created. And it says for this variable D, its type is a Python list. Okay, so that's what we can do. And also in Python and in a lot of, in all the programming languages, you can also comment out a line. So for example, for the print, if I add a pound sign or a hashtag sign at the front, you may notice that this line changed color. So that basically means we comment out this line. So when the program is executing all these lines, this comment line is going to be skipped. So that's how sometimes if you want to temporarily not executing a line, you can just comment it out by adding a pound sign at the beginning of this line. Okay, so now, for example, if I run this, it's not going to print that list because this line has been commented out. Okay, and also sometimes we can use comments to also add some notes to ourselves or to some other people who might be reading your code later. So for example, I can add a pound sign here and say this assign a number to a variable. Okay, so that's just some add notes. We can use that for commenting purposes as well. So that's the variable types. We talk about in Python, a variable can be an integer number or floating number. It can be a string and it can be list. So these are some of the most common ones. Okay. So now let's move on. So there are also some useful keyboard shortcuts. So one of the most common one is if you want to run a cell. So we talk about you can just click this play button, right? But if you're writing a lot of code, actually, oftentimes you will find it's easier to use some keyboard shortcut. So that's just Control plus Enter. So you press and hold Control, and then you hit Enter. So that would run the selected cell. Okay, so that's some of the, you'll find it's useful if you're writing a lot of code. And if you want to comment out lines, we talk about we can type in a pound sign at the beginning of the line, but oftentimes what you can also do is just to use your mouse to select all the lines you want to comment out. And then on the keyboard, press and hold Control, and then press the forward slash sign. And that would just comment all the lines that are being selected. And then you can do that one more time to just toggle through the comment and uncomment. So Control forward slash uncommon, comment, uncommon. You can just toggle through that. Okay, so that sometimes you'll find that useful as well. So that's that. So now let's continue. So the next thing I want to talk about is mathematical operations. So here we have a table here. So 3 columns. So the first is Python operators, plus, minus, and the second column is the meaning of that. And then the last column is one example. So most of these are pretty straightforward. We use the plus sign for addition. We use a minus sign for subtraction. And for multiplication, we use the star sign, which is the same on your keyboard. It's the same one as the one for the number 8. So that's for multiplication. And the division is a /. Okay. So one thing that is a little bit different, if you know some other programming language, is for exponents. We're using in Python, we use 2 star signs for that, or 2 asterisks. Okay. So for example, if you want to calculate 2 raised to the 3rd, the way to calculate that in Python is you first type in 2, and then the double asterisk indicates that is an exponent, and then you type in 3. Okay, so that's the mathematical operations in Python. So now let's go to an example here. So here we have an example where it tells you the volume of the sphere with the radius r is given in this formula. And then it asks, what is the volume of the sphere with a radius of 5? So how can we do this calculation? Given the radius of 5, can we actually calculate the volume of the sphere? So let's do the calculation here. So now I'll move my mouse to the cell below. I'll hit enter to add a few more lines. So here I'm gonna write my code, right? So for this problem, we already know the radius is r. So the first thing I can do is just to create a variable called r, and I will assign a value of 5. Okay, so that's when I say we create a variable called r, and we give it a value equals 5. So now we can create another variable called v, which stands for the volume. You can give it other names if you want. So v equals 2. And then I'll just essentially kind of translate this mathematical formula into the Python format. Okay. And in order to do that, it's a 4/3. So I'll just type in 4. And then / for division, 3. And then multiply pi. So I'll multiply, it's a star sign there. And for the pi, I can actually create another variable, let's call it pi, and we can give it a value, let's say equals to 3.1415. And then here in the next line, I'll just say multiply by this variable called pi, and then multiplying r raised to the 3rd. So I'll put in r here. Remember how we do exponent in Python? We use double asterisks followed by 3. Okay, so that's all we need to do essentially. So if I run this cell, so this time I'll just use my keyboard shortcut, the Control-Enter, to run this line. So actually nothing really happens because we didn't really ask it to output anything. So I can use a print function to print out some results. For example, I can say, for this print function, I can add some text. So to add some text, it has to be within the quotation mark. You can use single quotation or double quotation. So here within the quotation mark, I can just say something like the volume, and the volume is, and then I'll add a comma. And then for the next part, I'll just type in v here, which is a value we calculated. Okay, and now I'll do the Control-Enter again. So this would just give us the volume of the sphere based on this calculation. Okay, and if I want to round this number, this is too many decimal places. If I want to round this number for this v here, I can just apply use a function called round, and then I'll put this v within this another quotation mark here. And within this round function, I'll first type in v and then followed by comma. And for the next part, I need to specify how many decimal places I want to keep. So if I want to say keep 1 decimal places, I just put 1 here. Okay, and also make sure you have a matching number of closing brackets compared with the opening brackets, so it doesn't give you an error. Okay, so now if I run this code, Control-Enter, it will give us the volume, but this time round the number with 1 decimal places. Okay, so that's what we can do. And we can actually improve this a little bit because oftentimes pi is just a constant number, right? So oftentimes you do not want, for those constant numbers, you do not want to manually type those in because you may just make a mistake, right? So for these kind of numbers, oftentimes the good practice is we actually get this number from elsewhere rather than typing those in ourselves. So in order to get the value of pi, what I can do is to use one of the Python libraries called NumPy. So the way to use that is we first need to import this library. So I'll type in import. And then followed by the name of the library I want to import. So this library is called NumPy, which stands for numerical Python. And then oftentimes people give it a shorthand name. So we type in as, and then by convention, the name is NP. So the last part is essentially we're giving it a shorthand name, NP, for NumPy. Because when people just get started, they decided why type 5 letters when you can just type in 2 letters, right? And technically, you can give it whatever shorthand name you want, but by convention, people just call it NP, okay? So let's just call this NP. And once we have done that, actually, now I'll just comment out this line for the pi. I'll use the control / to comment that out. And here within the calculation, now I'm gonna just first call this library NP. And then for this library, there's actually already have this value of pi saved. So I can just type in np.pi to get this value, okay? So now if we run this cell one more time, control enter, we would just get to the same value, but this time the pi is actually directly obtained from this library other than we typed this ourselves. Okay, so this is how we can use Python just like as a calculator. And now I'm actually going to add another cell under this cell. So in the notebook, if you want to add another cell, if I want to add another cell for coding purposes, I'll just click this button for add a code cell. So now I have another cell below here. So here I want to also show you that we can do this calculation by using a function, using a Python function. So if you want to create a function in Python, you start by typing def stands for define, and then we can just followed by the name of the function. You can give it whatever name you want, but here I'll just call this function volume, and then followed by a pair of parentheses. And within the parentheses, you want to define the input to this function. So here, for this function of the volume, the input would be the radius. So I'll just type in R as my input. And then at the very end, I'll need to specify a colon, okay? So the colon is to specify whatever follows this line is going to be within the definition of this function. So then now I'll just hit enter. So now I'll just start typing whatever this function is. For example, I can type something. I can actually just copy and paste the line from the previous cell. So I'll just copy this line for the v equals to this, and then I'll move my mouse here and paste it here, okay? So, and because that is essentially how we calculate the volume based on the radius. So lastly, we need to specify what do we want this function to return, okay? So I'll just type in return space. And then for this one, we'll just need to return v, which is a volume, okay? So I'll just type in return v. So now we have this function defined. I'll add another code cell below that. So now I'll just run this cell of our definition of this function. So in the next cell, what I can do is simply just call this function to do the calculation for us. For example, I can just type the name of this function that we just defined, followed by the pair of parentheses. And here I can just say R equals to 5. So that would just do this calculation and with the radius of 5. So now if I run this cell, Control Enter, it will just give this as the value of the volume. Okay, so that's how you can use a Python function for this purpose. And now I'll add another cell to show you that in Python, actually, the input to the function can be multiple ones. For example, I can define another function, def, for define. And then for this one, I'll just do a simple, I'll just call it addition. So that's the name of my function. And I'll give it 2 arguments, or the inputs, A and B, followed by a colon, and then hit enter. And then now for this addition, I can simply say return. For this function, I'll just return A plus B. So I can do that as well. Okay. So now I'm going to run this cell for the addition. I'll add another code cell under that. And for now, I can just call this function called addition. And then I can just give whatever 2 numbers, 5 and 6, for example. And now if I run this cell, it will just give us the output, which is the addition of those 2 numbers. Okay, so here I just want to show you how you can define a function with multiple inputs. Okay, so that's in Python a Python function. So the way to do that is start by typing in def for define, followed by your function, and then followed by the arguments. And then you can specify what is the output you want this function to return. Okay, so one thing about Python is actually, if you know any other programming language, for the definition of the, for the second line, we actually have to wrap this within some curly brackets or some other kind of brackets. But in Python, we don't really need to do any of that. And the way that Python knows this is within, the second line is within the, this definition is in Python, we use indentation for that. Okay, indentation basically means the second line, actually there's 2 spaces here. Actually, if I remove this indentation, if we run this cell, it's actually going to give me an error. It says expected an indented block. Okay.
Hi, everyone. Can you hear me? If you could just put a message in the chat. I know Fred was having a little bit of trouble with the weather, some wind. So let's just give him, a minute or so and see if he can just get back on.
Okay. Continue. All right, I'm back.
Yay!
And I apologize. I think there was a power outage on my end. So where are we? Just give me one moment. Yeah, we still have 50 people here. That's good. I thought everyone already left. Okay, so let's continue. We talk about in Python, it's actually we use indentation to indicate the relationship between different code. So for example, here, if the next part is within this function, we'll have to use the correct indentation for that. So typically, you can use a tab key on your keyboard to add indentation. Okay, so now it runs. So it will not give me an error if I have the correct indentation. Okay, so for the next part, let's talk about, we talk about some of the most simple calculations, but there are actually a lot more you can use. So in NumPy library, for example, if you want to do the square root, or if you want to do some other functions, you can just call this function from the NumPy library. And the way to do that is np dot. np, again, is our shorthand name for NumPy, and then followed by the function. So here I provided a link to all the possible functions supported by NumPy library. You can take a look. It's a pretty comprehensive list of all the functions you might need. So for the next part, let's talk about the comparison operators. So in mathematical, we can operators, we can say A is greater than B, or A is smaller than B. So for all these, we can also have the Python operators for that. And for the majority of them, they're not really surprising, as you can see here. The second column is a Python operator. And the only thing that you might need to pay a little attention to is the last two row. So when we see when we say the A is equal to B, it's you have to use double equal sign for that. If we use a single equal sign, it basically means we're assigning the value of B to A. Okay, but if you want to say checking whether A and B are equal or not, you should use the double equal sign for that. Okay, just give me one moment. I just realized my keyboard is not refreshing. Okay, so now it's good. So that's that. So another important thing in Python is, and also in most other languages, is we can use if statement to perform different computations depending on conditions. So here, I'll give you one example for that. So if here in this cell below, I can type something like Michigan. That's, for example, we have a football game this weekend. Let's say Michigan would have a score of 38, okay? And Michigan is playing Wisconsin this weekend, so we can give a Wisconsin a score of, let's say, 35. Okay, so now we have the scores of these two teams. So we can use the if statement to perform different computations or operations. So for example, we can check if Michigan is greater than Wisconsin. And then you have to follow by a colon and then hit enter. So the colon is again to indicate whatever follows. It's a coding block within this condition. Okay. So as you can see here, once we hit enter, it will already automatically have the correct indentation for that. And for example, if Michigan scores higher than, oh, okay, I think I just checked the message. My webcam is frozen. Just give me one moment. Let me refresh that. I can certainly do that.
And Fred, if you can't, it's totally fine.
Yeah, I know how to do that. It happens before. I just needed to.
There you go.
So it should work now. So if Michigan's score is higher than that, we can print something. I'm gonna just use this print function. For example, if we want to print some text, we'll just add that to the quotation mark. We can say something like Michigan wins. Okay, and then if that is not true, we can say else. So for the else, actually need to start at the start of this line, because that's when we're checking another condition. So else also need to followed by a colon, and for that we can print something else. We'll print. Just make sure you have the correct. You have to wrap your text within the quotation mark, and then we can say something like Michigan did not win. Okay, maybe I'll add a sad face here. Okay, so now if I run, now we already have a very simple if-then statement. So if I just run this code, we can see that it says Michigan win. And that is this print function, because when they're checking the condition, Michigan's number is higher than Wisconsin's number, right? So that will, based on this condition, this is true. So whatever's within this coding block is going to be executed. So for example, let's give Wisconsin another touchdown. We'll add 7 points to Wisconsin. Now if I run this cell, you can see that it print out Michigan did not win. Okay, so that's because at this time, Michigan greater than Wisconsin, this condition is false. Okay, and so that's that. And we can actually also add more conditions for that. For example, we can add another condition, else if. So in Python, else if it's elif. So that stands for else if. And then I can say if the score is actually equal. So Michigan, again, if I want to specify equal, I need to type in 2 equal signs there. Okay, and then Wisconsin. And then followed by a colon. So if their scores are equal, I want to print out, for example, overtime. Okay, so now if I run this block, it still says Michigan did not win, because when they check the condition, the last one is true. Okay, and if I want to make it an equal score, let's give Wisconsin another field goal here, 3 points. Now if I run this, you can see now this condition is true. So their scores are equal. So this print function gets executed. Okay, so that's how you can set different conditions using the if statement. The next thing I want to talk about, again, is very important in any programming language, is the for loop. It essentially performs actions for each item in a collection. For example, I can do something like I can create a list. Let's call it people's ages. And then for list, I'll need to put that within the square brackets. And then I'll just put in some numbers here. You can put whatever numbers you want, but here I'll just put in 5 numbers here for a list of 5 numbers. And then we call that list ages. So for a for loop, we start by typing 4, and then I type in age. It's basically age, it's each of the item in that list. And then we say in ages, followed by a colon. Again, we have to type in colon here. And within this for loop, we can specify what do we want to do for each of the iteration. Okay. For example, the simplest thing, we can just print out this age. Okay. So now it's gonna just, if I run this cell, it would just print out those 5 numbers. Okay. So that's what you can do. Essentially, the for loop is performing the actions for each of the item in a collection. And here, the collection is just this list of the 5 numbers. So each time it will just print one of these. Okay. So that's what you can do. For the next part, we can also talk about emojis. So we can also print out using a for loop to print out these emojis. So here I'll just actually add some more coding cells here. So now I first need to run this cell. So now we created a variable called fruits, and that is basically we're using this quotation mark. It's essentially all these emojis of different fruits. So if I want to create a for loop for that, so first thing I'll need to do is to create a list. So first what I can do is to call this variable fruits, and then I'm using apply a method called a split, followed by a pair of parentheses. If I run this, it will just give me a list of each of the emojis. Okay, so now I can just use a for loop. For example, I say for fruit in, and now I'll just need to copy and paste this last cell here. So essentially, it's a list of those emojis of fruits, and then followed by a colon. And now I can just print out this fruit. Okay, so now if I run this cell, you can see we have this for loop essentially print out all these emojis from this list of fruits. Okay, so what you can also do here is let's do something slightly different. Let me create another variable called fruits underscore I like. So these are the fruits that I like. So I'll first add a quotation mark, and then I'll just select some of the emojis that I like. Okay, and make sure when you can also follow me, and you can pick different ones. For example, I like I believe that's a watermelon. So I'll copy and paste the watermelon here, followed by a space. So it has to be followed separated by a space, so we can split them later. And I also like strawberries. So I'll copy and paste the strawberry here. And I also like, let's say, kiwis. So copy and paste it here. So these are the 3 fruits I like. And I also like banana. So I'll add a banana here. So these are the 4 that I like. So now I'm going to run this one more time. So what I can do now is within this for loop, I can actually, instead of just print out all the fruits, I want to print out all I can use the if statement to print out only the fruit that I like. Okay, and the way I can do that is within this for loop, I say if, and then I can add another fruit in, and here what I can do is I just copy this variable that I just created, this name here. And then for this, I'll also need to split them. So I'll do I'll just type in dot split, and then followed by a colon. So now it's going to say that for each of the fruit in our original list, we check whether it's also in the list of the fruits that I like. And if that is true, then I will print out something, right? I can just print out, for example, I can add some text I like, and then followed by a comma, and then we'll just print out this fruit. Okay, so that's what we can do. And also you might need to add some indentation here to ensure this print function is within this if statement. Okay, so that's what we can do. And we can actually also add an else. So if this statement is not true, so else followed by a colon, so I can print something like I'll add a quotation mark, I do not like, and then I'll just print out this fruit. Okay, so that's what we need, all we need to do. And now if I run this cell, it will actually check each of the emojis, each of the fruits in our original list for this iteration. And for each of the emoji, the fruits, it's checking this condition, whether that fruit is also in the list that's from the fruits that I like. And if it's true, it prints out I like these fruits. And otherwise, it goes to this else condition. It'll just print out I do not like this fruit. Okay, so we can do that as well. So let me see how much time I have. We have about 20 minutes. So for the next part, I want to briefly talk about some of the descriptive statistics, what you can do in Python. So here, I already created a list for the ages. I'll just actually copy and paste it down there. And if you created a list here, you can also just copy and paste that list here. And I'll add a few more lines here. And now for this age, we can actually get some of the descriptive statistics to describe those numbers. So for example, the simple one is len, which stands for the length. So if I put within this len function, if I put the name of my list, ages, in there, if I run this, Control Enter, it will just return a number 5, meaning the length of this list is 5. There are 5 numbers here, okay? And if I want to know the sum of those 5 numbers, I can use the NumPy function, np dot. Again, np is our shorthand name for NumPy, which we imported earlier. So we can do the NumPy dot, and then sum, and then followed by the name of this list, which we call ages. Now, if I run this, it will just give us the sum of these 5 numbers, okay? And similarly, I'll just copy and paste this here. We can also do mean if we want to know the average of those numbers. So that's 29. The average age is 29. And we can also do the median, which is a middle number of the sorted list. So that would be 23. Okay, so you can do all these statistics using the NumPy functions. Of course, I can do some other ones like what is the oldest person here. The max age is 64. We can also do the minimum age, and we can also do the standard deviation, which is STD. That's the name of the function. It will give the standard deviation for the ages. And also, if we want to sort this list in order, what we can do is also just to call a function called a sort. So now we have a sorted list from the youngest to the oldest. Okay, so we can use the NumPy functions for all these purposes. Okay, so for the next part, we're going to march on to part 2, data analysis with Pandas. So Pandas is a very powerful Python library for performing data analysis. Here I provided a link. If you want to know more about this library, feel free to go to their official websites to see what you can do. So here, we're actually going to just use a data set. It's a CSV file, which I already uploaded on my website. But if you want to do some analysis later on for your own purposes, you can also use your own data sets for that. Okay, and here I'll just run this cell to have this URL. And for this data set, they are from they're about the college information, about over 700 colleges. And for each of the college, it gives us a number of information about that college, whether it's private or public, the number of applications, acceptance, and some other information about that college. Okay, so now if we want to read in the data, all we need to do, first we'll need to import the library first. So if here we wanted to use the NumPy library, so I'll just type in import NumPy. Oh, I'm sorry, the Pandas library, Pandas. And oftentimes by convention, people give it a shorthand name. It's called PD. So now this is the first line is just to import the library that we'll be using. And the second line is we want to read in our data. So I'll just type in PD. So that's the short name for our Pandas library. And then the function is called read underscore CSV. Okay, so that's the name of the function. And then I'll follow by a pair of parentheses. And within the parentheses, all we need to do is to pass this URL we just created earlier. So you'll first need to run this cell. And now I'll just copy the URL. You can also just type it in here. I'll paste the name here. So now this is all we need to do. And for the output of this function, we can just save it to the COL, stands for college. So that's the name of the table, where oftentimes people call that a data frame. So you can give it whatever name you want, but here I'll just use COL, stand for college. Okay. So now if I'm going to run this cell, we can actually import the data to our environment. So here it looks like nothing's happening because, again, we didn't really ask the notebook to output anything here. So what I can do here is just to do the COL dot head followed by a pair of parentheses. So that would just print out the first 5 rows of the imported data. So here is what the data table look like with all the informations. Okay. So here you can use the dot head to print out the first 5 rows. Also, we can do the COL dot tail to print out the last few rows. Okay. So if I run this, it would give us the last few rows, the last 5 rows of this data table. So that's that. So here I'll add a bunch of new code cells under this table. So what I can also do is, if we want to check how many number of rows and column are in this data frame, we can do the dot shape. And if we run this, it will tell us that this data table has 777 rows and there are 19 columns. Okay, so that's what we can check. And another thing we can do is we can also check the type of data that I have for each of the column. So that's COL.D types. So if we run this, it will give us for each of the column, what is the data type. So the int 64, that stands for its integer number. Okay. And object, you can just consider that as the string. Okay. Because, for example, the college name, so that is a string, and yes or no, that is also a string. And also float means it's a floating number. So this would give you information about what kind of data you're dealing with for each of the column. So let me add a bunch of more cells here. So other things we can do is from this data frame, this data table, we can also select a particular column. For example, the way to select a column from this data table or data frame is first you type in the name of this data frame. Here we call it COL, and then followed by square brackets. Okay, and within the square brackets, I'll use another quotation mark. And within the quotation mark, I'll just need to type in whatever the name of the column I want to select. For example, if I want to have the column name, for example, I can just copy that here and paste that within this quotation mark. And then if I run this, it will actually just only return this single column. Okay, so that's what we can do. And what you can also do is if you want to select a number of columns, you can also pass that as a list. So here, we'll just need to pass that with another list. So we'll actually need to add another pair of square brackets indicating that's a list. And within the list, I can just pass whatever the column I want to select. For example, we want to select, again, the column names. I'll pass that to here. And then I'll add a comma to separate the different ones. I'll add another quotation mark. And we can add another, let's say, another column called a personal. And then we can add another column we want to return. For example, expend, for expenditure. We can add that as a third column. So here it's basically saying that return me only these 3 columns. Okay, so you can do that by passing a list of the column names to this data frame. So the next thing we can do is we can also count the values for different columns. For example, all these universities, we have one column to indicate whether they're private or public. So what, for example, we might be interested to see how many of these universities are actually private in this data set. The way we can do that is first we can select this column for the private. So first, again, we type the name of the data frame followed by square brackets and then followed by a quotation mark. And here, that column is called a private. Okay. So now if I just run this, it will just return this column for us. But if I want to do a value count, I can just apply a method by first typing in a dot and followed by the method is called a value underscore count and followed by a parenthesis. And now if I run this, it will actually, it's called the value counts. I missed the S here. And now if I run this, it will actually just do a summary to calculate, to tell us that for this column, there are 565 colleges. They are private with corresponding with a value of yes, and 212 that are not private. Okay, so we can easily apply this function for that. And if you want to know the percentage, for this method, we can also pass a param argument called normalize equals to true. And then if I run this, it will give us the same information, but in terms of the percentage. For example, here we know that about 73% of the universities are private. So we can do that as well. Okay, so other things you can do about the data frame is we can actually create new columns based on the existing columns. So for example, for this data frame, I have one column for the number of applications received, and also the column for the number of the acceptance that the university sent out. So based on this column, we can actually calculate another column to indicate the acceptance rate. So the acceptance rate would just be the number of acceptance divided by the total number of applications. So the way to do that is actually quite simple. We start by typing the name of the data frame followed by square brackets and then the quotation mark. And then within the quotation mark, we just need to type in the name of the new column we want to create. For example, we can just call it accept underscore rate. You can give it whatever name you want. And for this one, we can calculate that based on another column. So I'll select this column. For example, it's for this one, we want to, first column we'll need is the APP, no, it should be the number of acceptance. So accept, so I'll paste it here. Okay, so that's the first number, the number of acceptance. Actually, I'll just copy and paste this part. And then this divided by, and then now I'll paste. And for the denominator, that should be the number of applications received. So APPS, so I'll copy and paste it here. Okay, so this is essentially to say we create a new column called acceptance rate. And the value for that is based on the acceptance divided by the number of applications. Now, if I run this cell, and we can also check the first few rows of this data frame. I'll do the head. Now, if we take a look at this data frame, if we scroll all the way toward the end, now if you look at the very last column here, we actually have this column that is indicating the acceptance rate, which is calculated based on the other two columns. Okay, so that's what we can do. And now if we want to sort all the universities based on their acceptance rate, we can also sort those the rows based on that. So here we can do the COL. That's a name for our data frame. So if you want to sort the rows, we can apply a method called sort underscore values. And then for this, we'll have to specify which columns we're using for this sorting, okay? And that argument is just called by. And then for the by, I can just add, if we want to sort the values based on their acceptance rate, so here I'll just copy the name of this column. And then I'll paste it here within this argument. So this is to say that now sort the data based on their acceptance rate. Okay, so now if we actually, let me actually also just only print out the first 5 rows. I'll do the head. Now if we actually check the, let me see, how can I scroll to the very, is this like that? I don't think so. So why it's not working? So it should be sorted based on their acceptance rate. So maybe I didn't run this. Let me run this one more time. So maybe I need to do the imp, set another argument called in place equals to true, in place. Okay, so now if we scroll all the way to the left, okay, so we have to say the in place equal to true, meaning that this change we want to apply to our original data table. As you can see here, now it's a sorted list based on this acceptance rate. So, you know, these are the most selective universities with a very low acceptance rate. Okay, so we can do that. And also, if you want to sort the data based on the different order with the highest acceptance rate on top, we can set another argument called ascending equals to false. And this argument by default is true. But here, if we set it to false, now it's gonna have the acceptance with highest acceptance rate on top. Okay, so that's what you can do as well. And just one more thing I want to talk about for this data frame is in Pandas, we can also easily check some of the descriptives to the data by simply applying a method called describe. And now if I run this, it will actually give me a summary of the statistical descriptive statistics for each of the numerical columns. So here there are too many decimal places. I can just also do around the numbers with, let's say, 1 decimal places. So we can do that as well. So you know what is mean value, standard deviation, and some of the other statistics as well. Okay, I think I'm running out of the time for this. But that's I think already a lot of information for you to absorb. For the last 2 minutes, I want to briefly talk about, there are some additional resources you can, if you want to further learn how to use Python, and especially for data analysis. So here I provided 3 links for that. And for the first link, actually, it's a much longer version of this workshop. So that was a workshop I conducted back in March. And we have the entire workshop recorded on YouTube, uploaded on YouTube. So if you want to know more, I would encourage you to go through this YouTube video. It's about 4.5 hours. If you want to know more about Python and performing data analysis in Python. Okay. And this is a Jupyter Notebook. This is a Google Colab. And if you want to actually do more intensive coding in Python, I would also encourage you to check out installing the Jupyter Notebook, which is like a local version of this notebook that you can just run all these on your local machine. So the second link, it's a PDF file that gives you the instructions on how you can install this Jupyter Notebook on your own computer, so you don't need to use the Google Colab for that. And lastly, we have some Pandas cheat sheet if you want to know more functions and method in terms of how you can do different things with the data that you imported into Python. So that's the end of this workshop. Again, like I mentioned earlier, we are going to send you, if you provided your email address to us, we're going to send all these informations with all the links to you after this workshop. And I believe the recording of this workshop is also going to be available to our audience as well. So that's all I have today. And thank you so much for your attendance and sticking toward the end. And if you have any questions, you can also email me as well. So I have my contact information here from this slide. So that's all I have. And I'll pass it to Christine for any further information.
Yeah, Fred, thank you so much and for your team. And I love that we can still do this, whether there's a pandemic or a power outage, everyone kind of sticks with it. So I so appreciate it. You know, one thing I remembered is I don't think that you ever ran the poll. I don't know if you want to run that just to see who is still here.
Yeah, I forgot to do that, but I'll launch the poll right now.
Okay.
So you should we just want to have an idea of who attended. So if you want to help us, please answer in that poll and we'll have a better idea of that.
Okay.
And thanks for reminding me, Kristen.
Yeah, no problem. And just to let everybody know, so next is a networking session. I put the link into the chat. And just so you know, there are going to be a couple of organizations there. Domino's Pizza, not for the pizza, but to talk about data science. And also Quicken and the American Mathematical Society. So please stop by their tables, especially if you're looking for a job or if you want to talk about what kind of data science they do at their organization. And so, Fred, you know, I'm not so familiar with the polls. What happens? Will it just pop up sort of the percentages?
Yes.
No.
It looks like it's still, the number is still going up.
Yeah, and I know we
Yeah, I
had
think that's
high
we
school.
have 38 people already. Yeah, that's all we have. So I'll end the poll
Okay.
and share the results, and so you can see the results. So it looks like people still sticking around are mostly the high school students. Yeah.
Yeah, that's awesome. And so, you know, whether you're in high school, you know, please go to the networking session and talk to the companies, talk to other people. And yes, I see a question came in. Is it Quicken Loans? Yes, it is Quicken Loans. I believe they are hiring. Domino's is going to be hiring in 2021. So thanks again, Fred and team. And hopefully we'll see you guys all at the networking session.
All right. Thanks for everybody.
Okay. Thank you. Bye-bye.
Thank you. Bye.